What's going on, everyone? Alan here. Wanted to talk to you about this new form of the law of signs that we're going to have to deal with every once in a while. It's got a whole section in our text that's dedicated to it. It's titled The Ambiguous Case for our law of signs that we talked about in depth the last section. So this one should be short and sweet, but I wanted to let you know that this one can be a little bit troublesome for some people. So try to go slow and make sure that everyone understands what these special cases are. Here we go. So, as I mentioned, we're going to dedicate um, this whole section to just this special example. And I think you might have seen it already. I bolded it pretty large. Um, but this scenario right here, which was our case number two, um, when we're trying to solve these oblique triangles, remember, they're going to have to give us three parts. Half of the unknowns, they're going to have to give us three of them. So, uh, in this case, when we were given an angle and then two sides, so that angle is not included. Most books aren't going to write ASS for obvious reasons. Okay, they're not going to put explicitive words in the text. So I like to put ASS to remind you to not look like one, because this can be a tricky part where there's actually more than one triangle. When dealing with this angle side side scenario, which most books again are going to put SSA, side side angle, um, I wanted to remind you that this can be troublesome and you don't want to look like one. So make sure that you check for all of the possible cases. So, real quickly, wanted to talk to you about what it means to be ambiguous. So, I wrote down the definition here for you, and that is basically that it can be interpreted more than one way. Okay. And so, for us, we have to make sure that we look for that whenever we have an angle side side scenario. Okay. So, when dealing with this, there are three different cases that could arise given the angle and two consecutive sides. And you can probably guess what cases those are, but just in case, I'm going to let you know. Every once in a while, they're going to try to fool you right from the start. They're going to give you an angle and two sides to where you couldn't even form a triangle, meaning that there are zero triangles that can actually exist. Okay. Most of the time, what's going to end up happening, of course, we're going to have one and only one triangle. But that special case that can actually happen when we have this scenario, and you don't want to look like an ASS, make sure you check for it. There's a possibility of actually two triangles that can exist given an angle and two sides. So this is the one that we're going to have to worry about the most. It requires the most work, which is where a lot of students really struggle, because this is where, you're going to have to end up finding much more, dare I say it, twice as much more things that were unknown or not listed than normal. The one triangle we already did last section. Pretty simple. You guys know what to do. And then zero, I'll talk about when that happens as well. But we'll even get into that more in the next section too. So you'll start to see this stuff repeat over and over. And hopefully, as you guys practice, it will become easier and easier. But with this new special case for the angle side side, be careful, because there can be zero, one, or in this case, the one that most students struggle with to understand and comprehend, two triangles. So to kind of go through this and show you, I wanted to give you the visual, as I always try to do, so that you understand. If we are given an angle and two consecutive sides, again, you want to make sure that you're understanding what's going on. Okay. So in this case, if I had an angle A and two sides, A and B, you can see I have that good ratio going on with both angle A and side A and some other side, in this case, side B. Now, if you notice, side A isn't very long. So no matter how I swung this around, I wouldn't be able to connect and make a triangle. So in that case, no triangle exists. We're going to call this the triangle inequality theorem later on down the road. And what that basically states is that any two sides of a triangle, their sum has to be greater than the third side. So for example, if I was to give you a 3, 4, 8 triangle, if I took the biggest side with any of the other ones, obviously it's going to be greater than the other because this one already is. So the one case that you really want to check is the sum of the two smallest sides versus the largest. So in this case, if I was to kind of draw this out for you and show you that I had, let's say, a length of 8 here, okay? And then from there, I built this up as a length of 3, and then this was a length of 4. Well, if I was to take these and try to form a triangle by pivoting this down here on its vertex, and then I pivoted this one down here on its vertex, you can see that they would never meet. And so the quick, easy way to show that is that 3 plus 4 is not greater than 8. If it was 4 and 4, then it would be exactly 8, and this would be a little bit longer, and it would have hit exactly right in the middle. And so you could see that that still can't form a triangle. That's why it has to strictly be greater than. Okay? And if it were bigger, so let's say we had a 4, 5, and a 7, and I drew that out. And I started taking those just like a bridge, and I started pushing each one of those down. You can see that they would meet at a specific point. And at that specific point, I would then be able to take this length and draw it to there, and I'd be able to take this length and draw it to there. And that would allow me to have a triangle. Okay, not necessarily a right triangle, but a triangle. So when one triangle exists is when we either have a 90-degree angle going on or not. And in this case, this is what's going to happen most of the time. We will have just one triangle. All right. And that is when that length that we talked about over here being too short on either one of those is long enough. And by enough, I mean that it would form a triangle, either a really nice triangle like a right triangle, or it would just have a longer side that I could then connect the one that I had and then find that other one on the bottom that we don't know yet. All right. But here's the weird, strange case, the ambiguous case, so to speak, is when two triangles exist. And that is if we were to take that length here, what they gave me, remember, angle, side, side. And that A length here, which is the same as here, if I was to swing it from one side to the other with the same length, it's still being that same length of A, you can see that I'd have one triangle right here, or I could actually have this bigger triangle here. And so unfortunately with that, there are two scenarios given that angle and that side length B and A. We'd actually have none of those given parts change. The A, angle A, and the little B and A, the side lengths, I can actually find two angle big B's, right? One would be this B right here that would pertain to this side, this angle, which is obtuse, or I would have this side length B for this smaller angle there, B1, they're calling it, okay? Which would also mean that we would have this smaller length here, which would be from angle C. So this would be little c, and since we're calling this B2, we call it little c2, or we'd have this bigger, longer length that goes with this other swing of the angle A, or side A, excuse me. And this longer side would be pertaining to this. So we would call this C1. So in order to find these, it's going to be a little bit tricky, but I wanted to give you the visual of these things first so that you can kind of have an idea of what we're dealing with. Now, a lot of the books will give you big, long, drawn out details, and they ask you to compare the A to the H. And if they're equal, then it's going to be a right triangle. If it's smaller than H, then it can't be one. If it's smaller, the A is bigger than our height, then it could be one, or it could be two. Let me try to make this very, very simple and clear for you, okay? And I'm going to do that by example. So let's take a look at this first example here. Right away, hopefully you notice that we have two things that we like. We have a little c and a angle, big C. That allows us immediately to be able to utilize the law of sines. And since we are given side length A, we're going to use sine of capital A to find that angle. And so what I'm going to set up here off to the side is the sine of A over little a, 17.9, in this case centimeters, equals, remember you just got to be consistent with these, I'm going to put sine of angle C. Now I don't like the whole, hopefully you remember what that is, minutes. 75 degrees, 30 minutes. Remember how many minutes were in 1 degree? Hopefully you said 60, because if I have 30, then that means I have half. And so this is equivalent to writing 75.5 degrees. So I will write that here rather than using the 30 minutes and having to change my calculator to DMS, degrees, minutes, seconds. Now notice I put the angles on top. So again, I got to be consistent. And since I know angle C is 75.5, then I will put side C on bottom as 13.2. And just like we did in the previous section, we'll utilize our law of sines by multiplying by the 17.9 to both sides. Now I'm not going to keep writing the units because hopefully you'll see that anything divided by itself is 1, and the units would also cancel out here. So the only thing that we're left with is degrees, and that's good because we wanted to find the angle for A. And hopefully you remember, in order to find angles, what operation do we have to use that we studied in the previous unit? Hopefully you remember. If not, I'll say it in just a second, because what we have left on the left side of our equation is the sine of A, and what is equal to all of this on the right, we'd have to punch into our calculator. And in order to do that, we're going to get out some number, and remember what we're actually trying to find is angle A. So if I want to change that number that I'm going to get by multiplying all of this out, then in order to reverse the order, hopefully you said it and remembered, we're going to have to do the inverse, either arc sine or inverse sine, however you want to write it, of that big nasty number that we got. And now we have our angle A. And so in order to do this, I'm going to pull out the calculator real quick and start with the sine of 75.5. And it was multiplied times 17.9. And then we took that and we had to divide it by 13.2. And when we get that, we get 1 point something. Now, I don't know if you guys remember, what we were trying to find was the inverse, the angle for sine that gives us 1.3 something, something, something. Now, I know that a lot of you guys aren't going to know what to do to here. You're not going to recognize it, but you may know to just plug it into your calculator by doing the inverse sine of whatever we had as our answer. So I'm going to hit second and answer. And when I hit equals, you're going to notice I get a calculator domain. And that's on purpose. That is something that should have happened, but now I want you guys to remember why. Hopefully you recall a few units ago, when we were graphing sine, and we did our 4 quarters in either direction, and they were all of our reference angles we could find, but we said the quadrantal angles would be even easier to find. And we did that in both directions. And we said what we would get for each of these things for sine, since it's the y over the r and we're on the unit circle, we're only looking at the y values. We said, where would it start? And hopefully you remember sine started at 0. Then it went to 1, back to 0, to -1, and then back to 0. And this was the shape of our sine curve. And we said that it would do the same thing on the other side, the negative side, and therefore the maximum amount that we would ever get with this, we said would be 1. And the minimum amount would be -1. So we know that sine always has to be between 1 and -1. And if you remember, the value that we got out on this was 1.3-ish. And therefore, what does that mean? When they ask us to solve a triangle, remember that means to find all the angles and all the sides that we have yet to find, which meant we needed angle A, we had angle C, we needed angle B, and we needed side length B. The cool thing is we don't have to find any of them, because this number here that we got from all of this came out bigger than 1. We know that that cannot happen. Whether it's 1 or -1, positive or negative, we cannot ever have a number greater than 1. So in this case, whether it's positive or negative, we cannot ever have something greater than 1, and that's what we got. Then there is no angle A that gives us that value, which means when they told us these specific sides for this specific angle, we cannot have a triangle. So unfortunately, we have to put that no triangle exists, which is good and bad. Bad because we weren't able to do what they asked us to do and solve. Good because we're done. There's absolutely nothing else we can do, so therefore we move on. So hopefully that makes sense why every once in a while you will have one of the cases that we discussed, no triangle, even though it doesn't always appear to be that way. So be careful when you're working with these. They can try to trick you a little bit, but I know you guys are all too smart for that. So the last thing I wanted to make sure is just kind of a recap of this. But basically what this is saying is what I mentioned to you already. We usually will get, for our angle for sine, something between 0 and 1. Okay, whether that's negative or whatever, doesn't matter, but something less than 1. If it's equal to 1, then we know that it is a right angle, and there's only obviously one triangle that exists. But this is the ambiguous case right here that we got to worry about. And whatever that first angle is that we find, we know that it is going to be the supplement to that. And remember, that just tells us there's a possibility, doesn't mean that it's going to yield 2 triangles like we saw in example 2. Okay. And of course, step 3 just mentions, hey, make sure that your answers make sense. Okay. The smallest angle will have the smallest side. The largest angle, the largest side, and the middle, the middle. One other thing, this kind of goes through and just it's more for your notes than anything else. When applying the law of sines, make sure that you check to see if a triangle exists. And when that will not happen is when you go to find an angle by using the inverse and you get a value bigger than 1 or -1. Okay. Remember, if it's equal to 1, then that means we have that one triangle where our angle is going to be 90 degrees. And then the case that we have to worry about most often is we're going to get something between 0 and 1, or between -1 and 1. like our sine curve when we graphed. In order to check, all you got to do is make sure that that second angle that you find, which is going to be the supplement of the first, when you add it to the original angle that was given, it has to strictly be less than 180 degrees in order to get a third angle and therefore create a second triangle.